Hi and hello from my side. My name is Matthias Pfuhl. I'm a project and service engineer here at Pro-micron. I'm with the Pro-micron for about 2 years now. And as said, I'm as a project and service engineer employed at the Pro-micron. Today's session is about digital assistant systems for the machinist. You can see it here right in front of me, the so-called Spike Assist. And to give you a bit of an insight what the Spike Assist is meant for, or what's the use case of the Spike Assist, I had the chance to talk to my colleague Tim Teufel last week. He's a former machinist in the tool and mold making industry, so single batch size industry. And we had a chat last week. We recorded this chat, obviously, and I'd like to show it to you right now. Oh, and before I start the video, I need to apologize for the bad hair that I had last week when we recorded the video. I wasn't able to attend a barber by this time, but hi, I'm here with my colleague Tim Teufel today. He's a former machine operator in the mold making and tool making industry. So industry which mainly runs single size batch sizes. So Tim, can you tell me which were the main challenges and problems you encountered during your everyday work life?
Main challenge was the required high precision and quality for the first part on, since we didn't had a reference or one-in part, and often had to handle multiple machines as program runtimes are sometimes long, and you needed to another process on another machine in the meantime.
So as far as I know, especially in the mold making industry, you often use quite expensive tools. How did you ensure that you ran the tool to the maximum tool life? And on the other side, how did you ensure that you received best surface quality? How did you use your tool to the maximum tool lifetime? How can you ensure this?
There are, of course, imperial value about the tool life and process parameters we used to work with. Of course, you need some time of experience to acquire the imperial wealth, especially when high quality demands are placed on, for example, the first surface. A new tool is set up, even if current tool can't still be used for retained parts.
So speaking about experience, what kind of experience did you require as your job as machine operator in single batch size industry? Which information did you receive from the process?
Of course, hearing is very important. Does my tool run quietly? Any abnormal sounds? Do I have vibrations? No, nowadays, the machining also gives me some information, for example, current power, consumability of the spindle, but this is mainly in washing processes.
So in everyday's life, we often use assistance tools. Could you imagine to use an assistance system in the shipping or machining industry as well?
It's just like in the car, where I also have advanced warning systems such as blind spot assist or pet terrain detection, which warn me of dangerous situations.
Yeah, and this is quite precisely what the Spike Assist is meant for. It's meant as an assistant and support tool, even for the experienced machinist, to give him more precise and detailed insights into the process, just like with the blind spot detection you mentioned, so that he can see information about the process he wasn't able to see previously. If Tim is about to watch this video afterwards, Tim, thank you very much for your time you spent me last week, so we were able to get a bit of an insight into your previous work life and to get a bit an insight of what the challenges are in machining, especially in the single size or medium size batch size machining. So as you said, or as Tim said, there are quite a lot of requirements he needs to achieve. So he has high demands on precision and quality. He also has often to handle multiple machines. And of course, he has very expensive tools and also workpieces he needs to manage correctly so that he does not cause lots of damages. And on the other hand, he only has quite a bit of process feedback from the machine he can work with. There's, for example, the experience Tim talked about. So meaning you can, of course, gain a lot of experience, but if you are new in this job, or even with the experience, you still need to be a very skilled worker to see and hear what the process is telling you. Seeing and hearing, good bullet points. Of course, you can hear if there is a vibration in the machine, or on the other hand, you can see if the chips are blue or slightly red colored. But this is always sort of individual by each person. So it would be way better if you just can use an assistant tool like in the car. You do not listen to your engine if how high does my engine turn, how high is the RPM. You do not listen to the engine to get this knowledge. You just look into your cockpit and you see the torque and the speed directly visualized. And then we, of course, have some sort of assistance systems who warn us in case of any danger. So, for example, distance warning or the blind spot detection, especially with the blind spot detection, this gives us an insight into the process or into the driving process we haven't had before. Even the skilled driver cannot see anything which is in the blind spot because it is, as it said, a blind spot. And that's the same with the spike assist. Even the skilled worker cannot see everything which is in the process. And with the spike assist, we try to give this skilled worker and also the new workers in machining industry more insight into their processes. How this could look like is visualized in this short video clip. So spike assist, your process body, it's really meant as a body, as an assistant tool for the machinist. We now see a new tool during the process. On the left-hand side of the panel, you can see the bending moment, right-hand side the torque, and in the middle the spike polar, which visualizes each single cutting edge. Now, during process, you saw that the bending moment was at a quite low level, and the spike polar looked quite good. We now inserted a already worn tool. And what we can see is that the forces are way higher, and there it is, the forces reached a critical level. So a alert system goes off and sends a push notification to the smartphone or the smartwatch of the machinist, so he can react if he's on another machine because he had to handle 2 or 3 machines. He can go back to this one machine and see if everything is fine, if the tool can still be used, and decide what to do with the process. So it's not necessary for him to stand by the machine all the time just to see if the process is running fine or not, because he will get the information remotely via his smartphone or smartwatch. So what are we about to talk today? First of all, I'd like to start with a little insight into the spike technology in general. What is spike and also what is spike assist? Then we'll directly move to our DMG machine to show you spike assist live during machining. Afterwards, we'll go on with the hardware and software components that come with the spike assist, and we'll end this session today with the availability and pricing of the spike assist system. So to start off, what is spike? What is the user approach of spike? There are 2 main topics of spike. One is the diagnosis. So a systematic mistake can be detected with the spike measurement system, in this case, the spike expert line solution, which most of you will know already. It is meant for offline analysis of processes to either use it in R&D for tool making industry, but also R&D in the pre-serial production to detect any systematic errors and to optimize your processes. And then we have the second part, which is monitoring, process monitoring. There we have the spike easy inline. Those of you who attended our last day's sessions already got a clue of what spike easy inline means. Those of you who were not able to attend the webinars yesterday and the day before live, I'd strongly advise you to go into YouTube or the DMAP homepage and watch the webinars in the real life afterwards, because they're really interesting to see what is possible with inline monitoring. But that's all not what we are about to talk today. We are talking about manual process monitoring and process control with the Spike Assist tool as a visualization tool, which gives me the insights of the process I haven't had by now to decide if my process is running good or bad and to decide how to handle it. Now, all the systems have one thing in common. They're using the unique spike technology. Unique spike technology means we are measuring forces directly where they occur. So you can see it on the left-hand side, the tool, and directly next to the tool, on the tool holder, we are measuring the forces that occur during process. Now, unique measurement system, there are others who are measuring forces as well, but we are doing something unique. We are measuring bending moments. Why do we measure bending moments? Well, it's quite easy. That's simple math. You have a moment that's always force times lever arm. Now, for the torsion, lever arm is only the radius of my tool. So I don't have a quite large radius, meaning my torsion is also on a quite low level because I don't have this high lever arm which multiplies by the force. We are measuring bending moment. You can see it visualized here. The measurement system sits around here in the spike assist. So we have approximately 10 times the lever arm length compared to the torsion, meaning our bending moment shows quite more differentiable values. In this case, we started off for the torsion with a percentage load of 30% for the first part. And until critical wear, we ended up with approximately 40% load in percentage, meaning we increased our load by around about 33%. Now for the bending moment, we started off about 25 to 30% and ended up at nearly 60%. So we had an increase by 100% or more from beginning of the process until the critical wear. This underlines the statement, the bending moment is way more sensitive than the torsion. And this is why we like to use the bending moment. And then there is another feature of the bending moment, which is unique in the spike system. This is the spike polar. The spike polar is the patented visualization of each single cutting edge based on the bending moment measurement. We measure bending moment over a holder coordinate system, which divides the holder into X and Y coordinates. And now the angular rotation of the holder and the tool are the same during process, meaning every time this cutting edge one gets into the tool, into the material, the load comes from the same force direction if I look onto the holder coordinate system. Now we are able to measure these forces and to create the static coordinate system which shows off the spike polar with each single cutting edge visualized. So in this case, you can see straight away cutting edge one seems a bit damaged. I have lower forces. I have a bit different shape of the spike polar in this area. So we can directly say, okay, this edge is damaged. We need to look at the tool. What is wrong? What's going on? Can I still use it? Can't I use it again? And this is what the spike polar is unique about. Now, that's basically it for the theoretical approaches of the spike technology. Let's move straight on to the machine because it's way more interesting to see things live in action than just talking about it. We prepared 3 tests for you on our machine. First, we'll start off with a process which runs on wrong parameter. Then we have a second process where the parameter have been corrected to the values given by tool manufacturer. And third, we'll insert a tool which already has reached some wear and see the difference of a new and a worn tool. After the live session on the machine, we prepared 2 other tests. We are not able to show you from the machine at the moment, but we prepared it before, so I can show you a video and pictures of it. It's about run-out mistakes and about drilling operations with the spike assist. So now let's go to my colleague Dirk, who's our machinist today, and see what he's prepared for us. Hi, Dirk, and welcome to the session. So you prepared some tests for us. We are now running a process where the parameters are not quite good. Can you give me a short input on the process parameter? What's wrong about them or the process parameter in general?
So at this machining process, we have a cutting speed of 130 meter per minute, a feed rate of 0.13 millimeter per tooth, and a cutting wide width of 1.3 millimeters.
Okay.
So that's too high feed, too high cutting wide width.
All right, so not optimal parameters for this tool. And you already can see on the screen on the left-hand side, as said, the bending moment, and we can see it reaches quite high levels. So we are going up to about 50% or above in this case, where the convex part of the tool of the part is. And we also see the spike polar, which changes its shape a little bit. Here on the back side, it's a quite even polar, spike polar, and on the other side, it's a bit more, seems to chatter. This is because of the input and output of the tool into the material. Now, you can see there are 2 points in the process, this edge here and the edge back there, where the forces reaches their highest levels. These edges are sort of critical for the process because this is where the tool load is the highest. You now just saw it. The bending moment exceeded the critical value of 50%, 58%. We now reached a force level of 64%. So machinist would now get a notification on his smartphone so he can move over to the machine and see what was wrong with the process. Now, if you look at the spike polar in this part of the process, we can see that it's a quite even spike polar. Forces are quite symmetrical applied to the tool. So look quite good, but we had too high force level due to wrong process parameter. Now, in this process step, the parameter were slightly adjusted. Dirk, can you tell me what have you changed for this process now?
I changed the feed rate to 1.0 millimeter per tooth and a cutting wide of 1 millimeter.
Okay, so we now have lower forces due to lower cutting depth and also lower feed rate. And we can see it right away. The force level is on a way lower level as we had before. I'll reset the maximum value so we can see how high we'll come with the good process parameter. So again, we can see spike polar in the back end is a quite smooth shape. And here in the front where we have the higher material which is chipped off, spike polar changes its shape slightly, which will occur just now. And as well, we have higher force levels as on the backhand side. Now there's one other thing you might already have noticed. The torsion is on a quite low level. We are here with about 0 to 4% torsion at the moment, and bending moment already exceeded up to 30%. This is what we've spoken about just before. The bending moment is way more sensitive compared to the torsion, meaning we can differentiate the forces way better and see way better what's going on in the process. Now we are again approaching the steps where the load increases here at the front end of the tool, of the part. This is because, as said, more material is chipped off due to this radius, which is machined here. So, Dirk, if you look at this process and at the spike assist measures which are shown to you, would you react in this case, or what are the information you can receive from this process?
So at this process, it looks really good. It's the best process parameters. I only would to change the NC program at the beginning. So when the tool comes in the material, I would change the CNC program.
Yeah. All right. So that's basically what you can see from the spike assist straight away. You might also slightly hear it that there is another sound, but in the spike bending moment and spike polar, you can see it straight away that the force level is way higher at what Dirk just said, entry and exit part of the tool. So you could now think about adjusting the parameter in this area slightly to reduce the load on your tool, and as a result, run the tool for a longer period of time because you reduce the maximum force applied to it. Now we are nearly about to reach the end, so we'll now have the highest load applied to the tool, or already had it in the previous step. Yeah, there we go. We now reached up to 45% with the wrong parameters. We exceeded our critical value. Now we are still below it, so machinist would not get a push notification from the system. He could just go on running this process on the other machine because this process, as Dirk said, looks quite fine and he does not need to react to it. Now, when the process is over, you'll see what plug and play with the spike assist means. Plug and play meaning we switch the tool in the machine and we switch the tool holder in the software. We tar the system once and then can go on with machining straight away. So there are no interruptions in your manufacturing process if you look at follow-up tools in the same part, because you can just switch them in the software easily with 2 clicks and go on machining, so you do not have any interruption in your machining process during this time. Now, this is a board tool. How long is this tool in use already?
I use the tool already 60 minutes, and normally I can use this tool like 90 minutes at the normal process with the normal parameters.
Okay, so basically we are about 2/3 of the tool lifetime at the moment, and we can see, or we will see later on, that the forces are higher compared to the good process with the new tool. You can see it here already. We reach now up to 26-30% of the tool load, and with the good process and good tool, we were in this period of the process at about 20%, so already above what we've seen before. Also interesting to mention and to notice the spike polar in this backside. You see the shape changed slightly of the spike polar. We had more straight lines with the good tool. Now we sort of have rounded edges, which is basically just the wear of the tool that we can see in the spike polar as well. The shape changes slightly, the cutting edge rounds out slightly, and this is what we can see in the spike polar and visualize directly. Now you see it, we already reached the 50% value of the critical. The critical value is set to 57%, so we nearly reached this critical hash already, and we still have some more turns to go on this part. So we will definitely exceed our critical value, which we defined up front. And again, the machine operator will get its notification, so he can look at the tool and decide if this tool is good to run or he can't go on with it. So yeah, again, as said, torsion did not change largely. We have quite low process parameter here in this area compared to the bending moment, which now reaches up to 54% and above. We are in the last
5 times.
So when we go on machining, there it was already. We now exceeded the 59%. We reached up to 62% at the entry, as Dirk said before already. The exit point and the entry point are the critical parts, and exactly at this part we exceeded our value. So if we just followed Dirk's recommendation earlier and changed the process parameter in this part, we might not have reached the critical value, but since we are some sort of stubborn and didn't change it, we exceeded the values and now need to look if my tool and also my part are still good and can be used. So Dirk, thank you very much for your time and your support here on the machine.
You're welcome.
Have a nice day and see you around. So what we just saw basically were 2 different things. One, wrong process parameter compared to good process parameter. On the left-hand side, you can see the bad process parameter. This was also last week when Dirk set up the test trial for today. The tool was, or the parameter he used were even more worse. So he reached up to 95% of the maximum tool load. But you also can see on the spike polar, there's loads of chattering. Spike polar does not look good compared to the good process where we can see the load is way lower and also the spike polar is in a good shape. So what we can see from these measures or from this visualization is that we did not have vibration with the good process, but have had some vibration with the bad process. We had a punctual overload of the tool or some sort of tool shocks at the entry and exit point of the tool, which Dirk also mentioned, we had this punctual load as well with the good process, but it was still at a level that it was okay for the tool and the process. And of course, if we look at the tool, at the part we machined right now, we would see a bad surface quality after machining compared to the way better surface quality with the good process parameter. Other thing we saw was a new tool compared to a worn tool. Now with the new tool, we had a quite stable process, no alert of the spike assist went off. And also we received, as said, the good surface quality. Now with the worn tool, we had way higher load onto the tool. We had higher vibration, chattering, so a less stable process. The alert went off, and yeah, we also received a better a bad surface quality because we had higher force levels, higher chattering. So basically, we just got all the information we needed to see the tool was good for the first part, but then after several parts, it was bad, and we needed to change it. And back to what Tim said at the entry or at the beginning of the session, he needed the experience over several months and years of time on the machine to define when the tool is good and when it's bad, and to know how long he can use it. And now he just can see it straight away in the software. He'll get the visualization and see this tool is good or this tool is bad. Now, I already said that we'll have two other use cases I'd like to show you. First is the runout mistake. So if we look at the process at this runout mistake, we can see that the forces are way higher at two flutes of this mill cutter. These are the two flutes where the runout mistake occurs. So we have 500 runout mistake. Oh, sorry for not translating runout mistake in this slide. But you can see that the force is way higher on this side of the spike polar. And as a result, these two cutting edges will see a increased wear compared to the other flutes. Also interesting to see and to mention, if we have a closer look into the process compared to the position, what we see already during machining, on this side of the part, we had lower forces, but we still can see these asymmetric tool load per cutting edge since we have higher forces on this side. And on the other side of the part, we had way higher forces, but also we can see this asymmetrical tool load, which was applied due to the runout mistake. Now, as a result from this runout mistakes, we of course also will result with bad surface quality. Maybe the tool might break or the cutting edges might break because the load is too high, and we basically don't have a stable process. Now, with some experience, and if you're a skilled worker, you also might see or hear when you have a runout mistake and you start machining. With the spike polar, you don't need the skill set, and you also have a obvious absolute measure that there is a runout mistake. The other thing I mentioned already is drilling with spike assist. We run 20 drill operations, and this is the drill entry side, drill exit side. If you look closer at it, you will see that some of these exit holes slightly moved away from their ideal position. So in this case, for instance, drill hole 11 and drill hole 14. If we compare this runout mistake or this drill deflection to the spike polar, we can see that the spike polar has changed its shape. In a good drilling process, which was, for instance, drill hole number 8, we don't have any radial forces applied to the tool. So the tool moves into the part straight only in one direction, is not deflected on any side radially, just moves in, goes out, and we don't have any radial deflection. Now, if we have this deflection of the tool, a radial force is applied to the tool. Why does this radial force change the spike polar, or how is it even possible that it is visualized with the spike polar? That's quite easy to explain. You can see it here on the left-hand side. There's a drill displayed, and we also see the radial force which is applied to the drill. Now, the process direction is just straight downwards, but the drill is deflected to one side. As I said when explaining the spike polar, the drill and the spike assist tool holder have the same angular rotation, meaning with each rotation of this drill, also the spike assist tool holder turns one time, and as a result, this radial force is applied one times around the spike assist holder, resulting in a perfect circle, which we receive in the spike polar, since we apply the same force from each of the possible angles of the 360-degree rotation. With increase of deflection, also the spike polar changes its shape slightly because we had a even higher deflection. We had an overlapping of the cutting edges, so the shape changed slightly, but still we came up with a bad spike polar, since it is not just a dot in the middle of the coordinate system. Now, we've seen what is possible with the spike assist in the machine. We've seen what is possible with the spike assist, not on the machine, but I just displayed it to you here. And we've spoken about spike assist and its compared tools, Spike Mobile. Now, question is, what do you require to set up your measures or your processes with the spike assist? Well, it's basically not much. All you need is the case which is standing here just in front of me on the desk. And inside of this case, there is obviously the spike assist tool holder. There comes the spike connect assist, which is the receiving unit. All the data is transmitted wirelessly between spike assist and receiving unit. So the receiving unit comes with this case. You get the software, charging station. The spike assist is powered by battery. So you can take it out of the machine if it's not in use, put it on the charging station, and next time you need to use it, you just put it back and can run it basically just as any other tool holder, because you don't have any cables inside the machine which might interfere your processes. Additionally, you can get a clamping wrench and the clamping nuts if you require them. And you can also receive the visualization panel, which displays the software. But you can, of course, use your own panels or notebooks for this as well. Now, what is displayed on this panel? It is the tool control center software as the spike assist cockpit. You've seen it during the process on the machine and also in the presentation already. We have the bending moment, which visualizes the relative load of bending onto the tool holder. We have the alert limit, which can be set to the defined limit. If the limit is exceeded, an alert will go off and notify the machine operator. We have the same thing with the torsion. Now, one thing to mention about the torsion. If the torsion is in positive direction, that means the spindle went into right spin. And if the torsion is into negative direction, meaning spindle rotation was a left spin of the spindle. And then we have our patented spike polar omnipresent in the middle of the cockpit, so you can see every time what is going on with your single cutting edges. So for instance, with this example, one cutting edge is missing, you will get this right away. So if the cutting edge breaks off, you will have the view immediately and can react, since your tool now is damaged and can't be used anymore. You might have noticed something additionally on the display during our machining tests. There are some settings you can encounter in the Spike cockpit. This is the Spike Cockpit Plus. You can define what 100% means. So by default, 100% is the maximum load the tool holder can compensate mechanically. Now you can set this 100% limit down in 3 steps. So you can see even smallest operations. So for instance, finishing processes or drill operations with very small and tiny tools, you will be able to see the forces and see the differences in the load applied if you set down the sensitivity to a lower grade. Then I've spoken about the Spike app quite a lot. Spike app is connected to the panel via the internet. So if the alert limit is reached, a notification will be sent over our Pro-micron servers, and you'll receive the alert signal on your smartphone or on your smartphone. So meaning if you have one machinist who is about to operate 3 or 4 machines at the same time or parallelly because it's needed, he can just connect his smartphone to each machine or to each panel of the machine and will get an alert notification if the signal is reached. So that's one way, receiving the alert notification if an alert is reached. Other way around is looking into the panel and see what happened in the past. So if you lead a shift of maybe 4 or 5 workers and you need to see if everything is fine with their machines, you don't need to walk around and have a look into every machine. You can connect the panels to your smartphone as well. And you can have a closer look into each single panel. You can see the reports which happened during the last period of time. You can open up one single report and get more detailed insight into this process which happened at that time. And you can see it here. You also see the alerts. So you can see if there went something wrong, and you can go to your machinist and say, hey, look, there was something wrong. What happened? Is the part still good? What have you done? And you are all the time have a good overview of what's happening in your machine hall. Now, we know what the Spike Assist is used for. We know what comes with the Spike Assist. Last question to cover: how can I receive the Spike Assist and what does it cost? Now, the smart thing about the Spike Assist, it's a rent model, meaning you can rent this Spike Assist system on a monthly basis. And within the first 3 months of this rent period, you can give it back to us. If you're not satisfied with the Spike Assist, or you say, oh no, it's not the correct thing for me, you can just give it back to us and everything is done. But if you say, yeah, that's exactly what I wanted, you can just rent it over a period of 48 months. And afterwards, you can decide if you keep it or give it back to us after this 48-month period. Now, the rent is only available for the HSK A63 CPER tool, which is displayed here. All the other tools or other tool holder configurations are available on request, but only for a sales opportunity. They are not for rent. But you also can get in touch with us, ask us for your configuration, and we'll see what price we can give you for another configuration. Now, you already used your Spike Assist, but then you say, oh, wait, he has spoken about Spike Expert Line, Spike Easy Inline. I want to go into more detail with the Spike systems. I want to have more insights into my process. I also want to have like my measures in absolute values and want to have them stored, or even have a fully integration into my machine and my CNC program. Then you can easily upgrade it. You can send the Spike Assist back to us. We can recalibrate the Spike Assist for you, so it can be used as a Spike Expert Line without any restrictions. All the measures are then displayed as absolute values, and you have the same functionality as you have with a Spike Expert Line. And if you want to go one step further and say, all right, now I need to have my machine fully integrated with Spike solution, I need a direct communication with the CNC code of my machine, I want to have my machine reacting to the measures of the Spike, you can upgrade this Expert Line by changing the receiving unit and connecting the receiving unit directly to the machine. So you have full control of your machine with Spike sensors. Now, to sum all the things up we've spoken about and also to come to an end, I just want to give you a short overview of the key benefits and key points, the unique selling points, as we like to name them, of the Spike Assist. It's very easy to set up in quite a low amount of time. You see it when we changed the tool. I just connected the Spike Assist in the software or changed the Spike Assist in the software. So it's very easy to set up. There's no cables that need to be laid. Just connect your receiving unit to the panel, connect the Spike with the receiving unit, and you're good to go. This leads me to the next point, very easy to handle. As said, wireless communication, the compatibility of Spike and receiving unit is preset, so you don't have to connect them on a quite different way. Just connect each to another with 2 clicks and you're good to go. You have a clean and detailed visualization of only what is necessary for your process on the Spike cockpit. And it's very easy to compare these values because you get an absolute measure. It says this tool ran at 40% load, and after 10 operations, it ran at 50% load. So you have a clean and easy message from the visualization cockpit all the time. And of course, you have the option to connect your smartphone or smartwatch with the software to get the alerts and see the protocols, what happened during the last period of time. So with this summary, I'd like to end for my part.
What is the battery life of the holder?
Yeah. So during operation period, meaning the holder running all the time, the battery life is about 16 hours. But this is only if the holder is running. So if the holder is inside the magazine, there's a acceleration sensor inside the spike assist. So if the holder is not in use, it will go into standby mode, and only if it's accelerated by spindle rotation, it will wake up. And in this wake up condition, the battery lasts up to 16 hours. In the standby mode, battery lifetime is approximately 1 month. All right. So if there are no further questions, I'd like to thank you for your attendance, and I hope you enjoyed the session today.